Hello. This is the fifth video on joining the code team, and it's going to be a walkthrough example of making an elevator. This is the same way you would make any subsystem for the robot. You start by making the new class, naming it subsystem.java. And in this case, because our elevator from last year had two motors, I only have two spark maxes, but for every motor, there's a spark max. So in our case, we have two. And then I want to keep track of the current height in the autonomous and for the drivers to be able to know where the elevator is at all times, even if they can't see the robot. From there, it's pretty simple. You create a constructor like you do in any Java program, which is the same name as a Java class. And then you have your motor 1 and motor 2. We're going to initialize these to be a new Spark Max with their specific device IDs. These are the can IDs that we created using the Rev client. And then from there, you do a basic config. This will be changed later on as we go through and we test our robots, and we're going to add voltage regulators and the position conversion factors. This changes how everything looks in our code from there. Then you have the closed loop and your PID. This is going to be very important for autonomous whenever we're going to be using path planner and wanting to make our elevator go to certain positions after a certain amount of time. These are the different values we're going to be doing. I just have the standard ones right now because I don't have the robot to test. Then you just click write configure, and this will configure the actual Spark maxes. And then I have for my code for getting the current height, each motor has an encoder, so you just get the motor encoder and then get the position at that for that motor. This will set the initial one to 0, and later on, in periodic, which is a method we're going to be writing for subsystem base, we're going to update it so whenever the periodic runs, which is practically every second while running the robot. The other two important methods that you're going to need to create is for every motor, you're going to need to set the speed at which it's going to be moving at, either up or down, left or right, spinning left or spinning right, and then you're going to need a stop one. From there, we're going to go to elevator commands. This is how we're going to connect the robot container to our actual subsystem that we create. Again, variables in the beginning, constructor. We're going to need an elevator, the elevator subsystem, and then we're going to need the joystick to make sure we read the inputs correctly. From there, just set them up like this. You can even do this dot for each of the different variables, and then you want to add requirements. Add requirements is for the command class that adds the requirements necessary for the robot to recognize the subsystem and to recognize all of the inputs. From there, I have a pretty basic if statement system that we made from last year, but you want to have a public void execute, and this is going to be where we use the methods based off of a joystick input that we created to move the robot up or down. And basically for the elevator, what we have set up is when the elevator height is 0, we allow the user input to be taking either A or B to move the elevator up to a certain point or up to L3. And these are going to be the speeds at which we go to. And you adapt this by adding further code, which will be and not, for example, a not statement that checks the current height being 1100, right? Which will run the code to be, which will run this certain speed up until the point right here, which is 1100. Would be a simple way to do it. Besides that, once you create your elevator commands and your elevator.java, you've created your subsystem completely, and now you just need to connect it to the actual robot, which is through the robot container. So you come over here and you create a private final elevator. You create a new elevator subsystem. You only do this once. Or a new elevator object, which is in this case our subsystem. And you come over here to configure bindings. And then the important thing, exactly like your drivetrain, you're going to be setting the default command for the command class to be the new elevator commands underscore elevator and the controller that you want to be using the elevator. And that's it. That's how you create a simple subsystem.